Hello everyone, thank you for watching this video. My name is Brent Griffin, and I'm going to talk about how to do mobile robot manipulation using pure object detection. Using this method, we see how object detection is practical for robot perception, how detection-based visual servo control can be learned in real time, and how our robot can perform mobile grasping using a single RGB camera. Let's talk about our object detection-based controller. We've seen the development of many object detection methods that perform well across many objects, while also supporting downstream tasks like segmentation or key point estimation. Our goal is to develop a detection-based robot perception and control framework that is reliable in unstructured settings. Like all feedback controllers, classic visual servo control starts with an error, which is based on the difference between image-based features and their desired position. In previous work, fiducial marker-based image features were commonly used. On the other hand, detection-based image features allow robots to use ordinary objects for visual servoing. The second part of visual servo control is minimizing errors using robot control inputs. We want our robot to learn a control policy in real time that relates detection-based image features to robot actuators. To accomplish this, we introduce our own update formulation, which enables us to learn visual servo control without any fiducial markers or calibration. In this example, our robot is learning to compare changes in camera and bounding box position in real time. After 13.3 seconds, our visual servo control model converges, and our robot is able to immediately track the ball using the learned detection-based controller. We repeat this experiment in consecutive trials, and additionally test against previous visual servo approaches. We find that in addition to learning much faster, our approach also reduces learning variability by 60 to 85%, leading to overall more reliable control. Let's look at some mobile robot grasping and talk about other ways we use detection. In this example, our robot detects a target object, the Pringles can, then uses detection-based visual servo control to align the object with the camera's optical axis. After collecting detections at known camera heights, we estimate the object's depth using changes in bounding box size and camera motion. After this detection-based depth estimate converges, we also use detection-based grasping. We rotate the camera to find the best fitting bounding box, then apply a parallel grasp at the box's center and estimated depth. Finally, we place the grasped object in a bin and repeat this process for the remaining target objects. Throughout this entire process, our robot's only external sensor is a single RGB camera. While standard object detection only works for known objects, our robot learns new objects from robot-collected data using a process called task-focused few-shot object detection. Consider a task where our robot needs to find a new object. After gathering images throughout the environment, our robot asks the user to specify an image with the object in view. The user then drags a bounding box around the object, and our robot learns from this few-shot example. Using this process, our robot learns visual servo control from a single click of annotation, and learns to manipulate new objects in clutter using less than a minute of annotation per object. To encourage future detection research for robotics, we've created the TFOD benchmark. The TFOD benchmark is configurable across a variety of few-shot settings and views YCB dataset objects from a robot's perspective for mobile manipulation. Thank you for watching this video. If you want to use the TFOD benchmark for your own work or learn more about this approach, feel free to check out the paper.